Hello everyone, thanks for coming. Today we are going to do a review of our week 6 lecture. So in this week we talk about the chain rule for multivariate function. Similar to chain rule for univariate function, suppose the function z is a function of two variables, x and y, where x and y are both differentiable functions of t. In this case, we can take the derivative of z with respect to t. Suppose z is the differentiable function of x and y. dz dt equals to partial f partial x times dx dt plus partial f partial y times dy dt. Also, if we have a function of n variables, each of the independent variables themselves are a function of another n variables, then partial u partial ti equals to the summation of partial u partial xj times partial xj partial ti when we sum j from 1 to n for each I equals to 1 to 2n. Yeah, so this is the general multivariate version of the chain rule. So using the chain rule, we can get the differentiation rule for implicit functions. Suppose y is determined by capital F of x and y equals to 0, then the derivative of y with respect to x equals to minus f partial x divided by partial f partial y. Suppose partial f partial y does not equal to 0. F of x, y, and z determines z equals to z of x and y, where x, y are two free variables, then partial z partial x equals to minus partial f partial x divided by partial f partial z, and partial z partial y equals to minus partial f partial y divided by partial f partial z. So this is the implicit function differentiation rule for a function of three variables. So the derivation for this formula are just to take the partial derivative of this capital F with respect to x and with respect to y in order to get this two relation. Thanks for listening.